Hello everyone, I'm Siddharthan. I hope you had a good time working on this machine learning challenge. So in this video, I will be explaining you how we can solve this particular problem on machine learning. So I will be explaining you how you can take the raw data set that we have, how we can convert it into a more structured data frame, and how we can use different models and compare their accuracies using a single function. So these are the things that we will be discussing in today's video. Okay, so before getting started with this, I would like to explain you what are all the factors that I will be considering for choosing the winner of this particular challenge. Okay, so this is the file that I've given you where I've mentioned about the task details that you have in hand. So what are the things that you have to do and so on. So this is the workflow that I have mentioned here. So the first thing that you need to do is take this raw data set that we have in this text file, which contains only one column. Okay, so I'll just open this text file. So this is the data set that I have provided you. So as you can see here, this doesn't contain rows and columns. So this is not a typical CSV file that we are used to working. Okay, so this is a different file, so which contains only one column. Okay, and the first 24 columns represents the value of the first data points, and the next 24 columns represents the value for the next data point, and so on. So we need to take this file and convert it into a more structured data frame. So this is the very first step. Okay, so I'll see how you have worked on this. So let's say that you are using a different CSV file where it contains a more structured data, then I cannot take your code for consideration. Okay, so the main challenge here is how we are going to process this data. So the next thing I will be seeing here is the basic data pre-processing techniques and all of those things. So checking whether there are any missing values and other things. Okay, so if you have did any data analysis, that's really good, and if not, that's not an issue. So the main idea of this challenge is how we are going to process this data and how we are going to use the models for training. So that is all I am interested for this particular challenge. So in the upcoming challenges, I will be mentioning about all the data analysis part, and things like how we are going to process the data. Let's say that this particular data is highly imbalanced. So like, if you consider a complete data science project, let's say that we have this Parkinson's data. So this particular data has a very high imbalance. So I'll show you that. So you can see here that so here 1 represents a person with Parkinson's and 0 represents a person who is not affected with Parkinson's. So we can see that there is a clear imbalance between them. So we have more data points for persons with Parkinson's in this data set. So in a typical data science project, what we have to do is work with this imbalance and remove that imbalance. So we have certain methods for it. But in this particular challenge, I'm not looking for it. So this is all about working with this data set and so on. So if you did this, that is good, but I won't be taking that into consideration, because like there are certain limitations in this challenge. So you are requested to do these things. If you have done beyond this, that's good, but I cannot take that into evaluating and so on. So that is another thing that I wanted to mention. And the third is, you have to standardize the data and split the data into training data and testing data. So this is the twisted part of this challenge. So the correct way to standardize the data and to split the data is, you have to split your data into training data and testing data. So this is the first step, and then after that you need to standardize your data. So you have to fit and transform your training data, and you just have to transform your testing data. So if you have did this the other way around, let's say that you have standardized the entire data and then you have split it into training and test data, then it is not the correct way of doing things. So you will have some negative marks or something like that. Okay, so you have to first split the data into training data and testing data, and then you have to standardize it. So that is a reason why I have mentioned this. So this is like the twisted question that we used to see. So the correct way of doing this would be splitting it first and then standardizing it. Okay, and the next thing is, so this is very very important. So this is one thing that I will be seeing how we have worked on. So here you will be using four functions, only these four functions. So logistic regression, support vector machine classifier, which has a linear kernel, k nearest neighbors classifier, and random forest classifier. So you can just use the default parameters and so on. So I'm not much interested in what is the accuracy score and all. So I'm not that much interested in it. So what I'm interested in it is, you have to create a function. So this function should use these four models separately, and this function has to train the model separately and test the model separately, and it should give the accuracy score for all the four models. So I could see few codes. So a few people have sent me the codes, and I could see that they have created a function and they are passing this model as the parameter. So that is not how I wanted this to be. So you have to create this function, and when you run this function for once, it should give this 4 accuracy score. So that is what I was interested in. So if you didn't do that in that particular way, so I like that wouldn't be the correct way of doing this particular code. So this is what I'm expecting. So when you run this function once, it should give this 4 accuracy score. And finally, with the comparison of these default parameters for these models, we have to see which model has the highest accuracy, and you should write an inference of why that happens, why that particular model has high accuracy in this case. So these are all the things that I will be explaining in this particular video, in this code which I have done here. So in this, we'll be seeing why that happens and so on. So this is what we'll be discussing here. And yeah, finally, I have also mentioned that you don't need to do any optimization and tuning to increase the accuracy score. As I've told you, this is not about finding the highest accuracy or so on. So this is all about just understanding how we are going to implement this and how we are going to follow these instructions to build a code like this. So that is all I'm interested in. Okay, so as I've told earlier, so if you have worked on outliers, or if you are trying to work with the imbalance of the data set, but that is fine. But in this challenge, I didn't ask for it. So as I've told you, this is a basic challenge, so I will be considering only these 6 points for consideration if we in order to evaluate your code and so on. So that is one thing that I wanted to tell you. And the other main thing that I'll be considering is like what time you have sent me the code. So people who have sent me the code earlier will get an edge if there is a tiebreaker or something. Let's say that we have two codes, and these two codes are pretty similar, and we have to choose only one person between them. In that case, I will be looking at what time they have completed this. So a person who have completed this early will have an edge over the other person. And let's say that they have actually sent the codes at the same time. So let's consider this scenario. In that case, I will see whether that person has deployed the model or not. But I'm not looking for deployment as well. So this is not that tough. But I mean, I know that it requires some effort, but like I would say that I'm giving more priority for the time that they have sent me the code. So if you have sent me the code soon, then you will get more marks or something. So if there is a tiebreaker at that point, then only I will consider deployment. So deployment is the last part of this. Okay, so where the main factors for evaluating is the first 6 things. Okay, so in this video now, let's see how we can solve this particular challenge, and based on these factors, I'll announce a winner soon for this challenge very soon. Okay, so let's see. So the first step is I have imported my data set here. So I have uploaded my data set, which is Parkinson's disease raw data. So you can see here the data set that we have, which contains only one column, and it totally contains about 4,681 rows. So let's see how we can work with this. So I'm not saying that this is the only way to do this. So that is not the correct way of putting this. Like, we can solve this in multiple steps, and everyone has their own approach. So in this video, I'm explaining you what is the approach that I have taken. So some other person may have a more efficient way of doing this. I mean, all those things are fine, but it's just subjective. Okay, so let's see how I have solved this particular problem. So I'm not saying that this is the best way of solving this. So that is one main thing that you need to remember. Okay, so the first step is uploading the dataset, which is Parkinson's disease raw dataset, and then I'm importing all the basic libraries: NumPy, Pandas, train, test, split, standard scalar, and so on. So we have the 4 models here: logistic regression, support vector machine classifier, k nearest neighbor classifier, and random forest classifier. Okay, and then we have the accuracy score and so on. And so this is just running the first step, which is importing all the dependencies. Now we are going to process the data. As we have a text file where we have only one column, we are going to take this and convert it into a more structured data frame. So the main thing you can note here is we can read a text file through Pandas using the same read CSV function. Okay, so you don't have a separate function for reading the text file, so you can just use this read CSV function in order to read a text file. Okay, so mention this pd.read CSV, and the main thing that you need to mention here is header is equal to none. So if you don't mention this header is equal to none, so header is nothing but basically the column name. If you don't mention this, what happens is you can see the first row here. So the first row that we have is this PHON R01 S011. So this is like the ID of that particular data point. So let's say that these are the 24 observations. So now, so this is like S01 and 1. So this is S01 2. So these are two different data points: the first 24 lines and the second 24 lines. So this is like the ID. So if you don't mention this header is equal to none, what happens is Pandas will consider this first value as the header column. So when you run the code without this header is equal to none, your column name would be this. Okay, so this will be your column name. So we don't want that because that is the first value in our data frame. So we need to mention header is equal to none. In case, let's say that we have the column names in our data set, in that case we don't have to mention this. So in this case we can clearly see that we don't have any column names or so on, so we should mention header is equal to none. So that is our next step, which is loading the data into a CSV file. So I have already run all these cells, and also we have the outputs. So I'll just explain you what we have did in the code. Okay, and the next thing we are doing is we are printing the first 5 rows of the data frame as we used to do in all the steps. Okay, so all the use cases and so on. So we are just using this data.get. So I'm loading this data in a data frame called as data. So we are naming this as just data, and data.get will give us the first 5 rows in the data frame, right? So we have the first 5 rows in the data frame, and we are checking the data frame shape, which is 4680 comma 1, and we know that in Python indexing starts from 0, right? So totally we have 4680, which basically means we totally have 4681 rows where the first value is counted as 0. Okay, so this is the shape, and we know that it only contains one column. And now what we are going to understand here is, like I've told you that there are like the first 24 rows represents the first data point, right? So how I'm saying that is, you can see that 4680, right? So like yeah, so totally we have 4680. Now we need to determine how many data points are there. So how we can do that is, so you can just open your calculator. So I'm going to put the number of rows that I have, which is 4680, 4680, and this should be divided by 24. So what this basically means is, we are taking all the rows. So we are considering all the rows, and we are going to divide this by 24. So when we do that, we can find how many data points are there in this data frame. So you can see here totally we have 195 observations, and by this this is what I have mentioned here. So this data frame contains 195 observations and 24 features. If you don't know this, this is how you can find how many data points are there in this particular data set. So I have already given this value, but this is how you can find this. So we are taking the total number of rows that we have and dividing it by the number of values that we have. So this will tell us the number of data points that we have in a data set. Okay, so 4680 comma 1. Now what we are going to do is we are going to separate the first 24 values. So before that, we need to understand how we can determine that first 24 values represents one data point. So it is pretty simple. So we have this first data ID here, right? So the second data ID is this, right? So all the values between them represents the first data points. So if you consider the next one, so this is the third data point. So all the values from here to here represents my third data point. If you count this, there will be totally 24 values including this value. So this is how we can say that this contains 24 features. Okay, so now what I'm doing is I'm using the same let function. So we know that the normal let function without any parameters in this parenthesis will give you only the first 5 rows, whereas if you mention the number here, so what this basically means is, like if you mention 5 within this parenthesis, it will print the first 5 rows. If you mention 10 in this parenthesis, it will mention the first 10 rows. If like here we have mentioned 24 as the number, because we know that there are totally 24 values for one single data point, right? So I'm creating a new variable here. So that is what I'm doing here is, like we are getting the features and target for the first data points. As I've told you, this represents the data and the target for the first data point, right? Where I've also mentioned that if you start numbering the features from 0, the 17th feature will be your target column. So that is nothing but you can see the value here. So this one is my target column. Like if you start the numbering, so if let's say that we are giving the numbering for this first row as 0, then the numbering for this will be 17. So this will be my first the value for my first data points, and it totally contains 24 rows, where this one is my target column. Okay, so I'm going to separate the data. So I'm going to take the first 24 values alone. So that's why I'm using this get function. So I'm creating a variable called as data separate, and I'm using this data.get, and in this parenthesis I'm mentioning 24. So when I run this, I will get only this 24 values alone, and it will be stored in this variable called as data underscore separate. Okay, so that is the next step we are doing, and we can just print this data separate and see the values. So we have the values from 0 to 23. As you know, if you count this, we totally have 24 values because of this indexing 0. So this is the first data point values from this id to all the way up to 0.2864, which you can also refer here. So from this first value to this 0.2864 values. Now what we have to do is, we just have to transpose this data. So that is all we are interested in. So this is where linear algebra is very helpful for us. So if you have a good understanding on linear algebra, you can just look at this and say that I just want to take this data and I have to take a transpose of this. So this is why we need to have a good mathematical understanding on, concepts like linear algebra and other things. So this is just like a matrix with 24 rows and one column, and we have to convert this into a matrix with one row and 24 columns. So we just have to take the transpose of it, and that is the next step. So we just have to, we are just taking the transpose of this array. Like this will be in the form of a data frame, I think. So or else I'll do one thing. So I'll restart the runtime and I'll run this and show you. So first let's run the importing column, importing cell, and next is importing the data set, and we are printing the first 5 rows, data.shape, and we are creating this variable called as data separate. And you can also try to see what is the data type. So type data separate. As you can see here, this is also a type of a data frame. So this is also in the data frame type. Okay, so you can try to print this data frame. And now we are trying to find the transpose of it. So when you run this transpose, so you can see that all these 24 rows will be converted into 24 columns. So this data set now contains 1 rows and 24 columns, and we know that this is the general structure which we use for our machine learning use cases, right? So now what I'm going to do here is, as now I got this data and I'm going to remove this from my original data set. So you can see here, so now what I will do is I'll remove this 24 values, and after that I will just do the same thing that I did for this all these values. So what I will do is, so once I taken all these values, I will just delete all these values, and I'll take the next 24 set of values. Okay, so the next 24 values will be taken, and I'll take a transpose of this, and again I will remove this values, and I will go on to the next data point and so on. So this is how we work. Okay, so we don't have to do this manually. So we don't have to do this for all this 195 data points. So this is where we are going to use a for loop. So this is the for loop for doing that, where like we are taking the data frame, we are taking the transpose of first 24 columns, and then we are removing those 24 columns, and then we are moving on to the next column and so on. So that is the for loop. So before that, I'll explain you how we can remove the first 24 columns. So this part is about transposing the data, and this is regarding, so I'll just run all. Okay, so let me just run this. So this particular for loop may take some time. Okay, so this is completed. So let's go, let's continue the discussion. Yeah, so we have transposed the first data point, and then we are, so this is the code to remove the first 24 values. So data is equal to data.ilog. So ilog, so we are just locating this first 24 data points and we are removing. So when you mention the syntax like this, it will remove the first 24 data points, and this is called as slicing. So we are slicing the data frame where we are removing the first 24 values. So if you mention 10 in this place, it will remove the first 10 rows and so on. So this is how this ilog works. Okay, so we are removing this and we are storing it in the same data which is named as data. So we are removing the first data point values, which are the 24 values. Now if you just run this data.24, and when you mention this 24, you will get the second data point values, because we have deleted all these values. So we have deleted all the values from this point to this point. So your yet will give the next set of values. So you can see here, so this is my second data point. So now I have to do the same thing again and again for all the 195 observations. Okay, so this is my data.tail. So data.tail is, this is the last data point that we have in our data set. Okay, so which contains 4, 6, 7, 9 rows and so on. So now we can see the transposed data shape. So 1 comma 24 is nothing but this data frame. So you can see here, so transposed data is my like the first data point which is transposed now, which contains 1 row and 24 columns, right? So this is that data. So I'm just printing the shape of that transpose data, and now I'm creating a list. Okay, so this list contains the values from 0 to 23. I'll explain you what is the significance of this, but just wait, just hang in there. Okay, so we are creating a list. So this is how you can create a list which contains the value from 0 to 24. So this is a short way of doing this. So the one, like the other thing you can do in order to create a list is, like, what you have to do is, so you can just name your list as my list, and you have to have this square brackets and write the values from 0 to 23. So this is not an efficient way to do this. So instead what you can do is you can mention this list and mention a range 0 to 24. So this will create a list which will contain all the values from 0 up to 23. So 23 is like when we mention range 0 comma 24, this last number will be excluded. As you can see here, we have only up to 23 and the numbering will start from 0. So 0 to 23. So this is the thing that we want. Okay, so I'll explain you what is the importance of this. So now we are creating a for loop to do the same thing. Okay, so j is equal to 24 because I want to take the first 24 values of my data frame. So that's the idea. And we are creating a for loop for I in range 194. So 194 is nothing but the total number of data points that we have in our data set. If you remember, totally we had about 195 data points, and we have manually separated the first data point, right? So we don't need this anymore. So the remaining 195 minus 1, so we know that it's 194, so we need to mention 194 here. So we have already splitted the first data set, and we are just doing the same thing again. So we are creating a variable called as data underscore separate, and I'm taking the first 24 values. So we know that the value of j is 24, so we are taking 24 here and we are transposing the value. Okay, so they are transposing all those 24 values, and after that we are renaming the column names. So now I'll explain you what is the significance of this list. So if you come here, so you can see that this transpose data contains values, and we have column names as 0, 1, 2, 3, and so on, and we have the corresponding values here, right? So what happens, so this is my next set of values, and you can see here the next set of values as an index of 24, and then I have 25, 26, and so on. So when you take this second data point, transpose it, what happens, it will contain the column name as 24. So this particular value will contain the column name as 24. This will contain the column name as 25, and so on. So what happens, instead of the data getting added row wise, what happens is like it will create another 24 columns. So we don't want that to occur. So what basically happens is like now if I add these two data points, so the first data point and the second data point, now my data frame will contain 48 columns, and my first data point will contain the values for this first 24 values, and the next 24 values, all the values will be 0. And for the second data points, the values for 0 to 23 will be 0, and the next set of columns from this 24 to 47 will be all these values. So we don't want that. So in order to add that two data frames row wise, we need to rename the axis. So we need to rename all the index again from 0 to 23. So that is what, so 0 to 23 basically means 24 columns, right? So 0 to 23. So that's why we are setting the axis. So this is just like renaming the column name. So that's why we are doing it. So we are just doing all the things in the same way. The only difference is that we need to rename this column name. Okay, so in place is equal to false because we don't want to change the column name in the original data set. So first we are taking this j is equal to 24, and we are creating a for loop where we are running this for loop for 194 times. Okay, and when you run the for loop for the first time, it will create this data frame called as data separate, and it will take the data dot get j. So j is nothing but 24, right? So it will take this set of values, the values from this one all the way up to this particular value, and once this value has been taken, it will take the transpose of this data, and this transpose value will be stored in the data frame called as df. And in this df, and I'm renaming the column name, as I've told you what is the significance of this. So we are passing the list. So this column header is nothing but the list that we have created. So this is the list which contain the values from 0 to 23. Okay, and axis is equal to 1. So we are renaming the column name, right? So that's why we are naming the axis is equal to 1. If it is the row, we will mention axis is equal to 0 and so on, and then we have the in place. And now we are going to combine these two data frames. So two data frames is nothing but the first data point and the second data points. Okay, so we are doing that by, so we are creating a list with, and this particular list contain transpose data and df. Transpose data is just the first data point. So you can see here, so this is my first data point, right? So which is stored in the data frame called as transpose data, and my second data frame is stored in this df. So I'm taking these two data frames in this list, and I'm going to use the function pd.concat, which will join these two data frames. So I'm basically joining the two data points that I'm having now. So you need to mention the list which contain these two data points, which are transpose data and df, and axis is equal to 0. Now we are mentioning axis is equal to 0 because we want to add the data row wise, right? So we don't want to add that column wise, but we need to add that row wise. So that's why we are mentioning axis is equal to 0. within this pd.concat function, and again we are removing the first 24 columns. Okay, sorry, the first 24 rows. So what happens is, when the for loop runs for the first time, it will take the first 24 values alone, and it will take the transpose of it, and it will rename the column, and it will join the column with the previous data frame that we have. So that's all happens, and the next time happens, this is done for the next data points. So this is my first data points, and the second data point, and the second time it runs, and it will do the same for this particular value. Okay, so this process will go on for 194 time, and now all the data points will be converted into a more structured format. So you can see here, now the final data set is nothing but the transpose data. So we are concatenating all the data points separately, and we are storing it in this transpose data. Okay, and now we can try to print the head of this data frame, which will show us the first 5 rows of the data frames and so on. And the one issue that we have here is the index for all these values is 0, right? So we just need to change that. So before that, we are just checking the shape of the data frame, which is 194 rows and 24 columns, which is our desired format, right? So you can see here, as I mentioned you, there are totally 195 observations and 24 features. So this is our more structured data frame. So you can see the head here and the tail, the last 5 data points. And we are resetting the index. As I've told you, all the index values is 0 here, right? So we are resetting the index, and we have the ordered index 0, 1, 2, 3, and so on. So you can see the first column here, and this is the duplicate index, the original index that we have, which contains all the value as 0, right? So, and the name of this particular column is index, so we can just remove this. So this is not significant for us, so I'm just dropping the column. So you can see the main thing you need to note here is we are using the function called as reset index, which will give a new index for our data frame, and we are removing the previous index we had using this drop function. So I'm dropping the function called this and column called as index, which is my just this column. Okay, so axis is equal to 1, because while we are dropping a column, we need to mention axis is equal to 1. When we are dropping a row, we need to mention axis is equal to 1, axis is equal to 0. Okay, and now you can try to print the first 5 rows. You can see here, so now the index is in order 0, 1, 2, 3, 4, and so on. So now we can see the shape of the matrix, shape of the data frame, which is 195 observation and 24 columns. Okay, so and we are just checking whether there are any missing values. So you can try to find this using this Parkinson's data dot is null. So I'm renaming this data here. So you can see here, so we are renaming this transpose data into Parkinson's data. We are resetting the index here. So now on, the data frame name will be Parkinson data, and we are using the sysnull.sum to see whether there are any missing values in each column. So each number represents each column. So you can see here 0, 1, 2, 3, and so on. So each of this represents each column, but you can also rename the column names if you want. So that is up to you. Okay, and now we are checking how many values are there for the target variable 1 and the target variable 0 and so on. So we can see that there is an imbalance between that. So we will deal with this imbalance in a later video. So for now, I don't want to overload you with the information. So we will handle this later on. So I'll make a separate video on how you can handle these imbalances and so on. So for now, let's not do anything about this. So we have 147 values for the label 1 and 48 values for the label 0 and so on. And I've already mentioned you in this particular file that 1 represents people with Parkinson's and 0 represents an healthy person. Okay, so that's what I mentioned here. And the next main thing is, as I've told you earlier, you need to split your data before standardizing it. So it shouldn't be in this particular order. So first of all, you need to split your data into training data and test data, and then you need to standardize it. So this is one of the main things that you need to remember. Okay, so you can see here we are separating the data into features and targets. So as I've also mentioned in this file, that my 17th feature is my target column, which contains either 1 or 0. So that the 17th feature, the 17th column will go into my y variable, and x will contain all the remaining columns. So we are removing the 0 and 17th column. So 0 is nothing but the ID, so the ID of the person and so on. So we don't need this. So we just need all the other values. So we can just remove the 0 column also. So we are removing the 0th column and the 17th column. So where the 17th column is my target variable. Okay, and my y will be my the labels. So you can try to print this x and y, and the next step is splitting your data into training data and test data. So I'm creating 4 arrays: x train, x test, y train, and y test, where x train is my training data and y train is my corresponding labels. for this X train, and X test is my test data and Y test is my corresponding labels for this test data, and we are using this train test split function. Okay, so we need to mention X and Y. So X and Y is my data set that I have. Okay, so we are going to split this X and Y, and that's why we are mentioning it there. And test size is equal to 0.2. So 0.2 means like there are like we need 20% of the entire data as test data. Okay, and the remaining 80% of my data will be my training data. So and then we have this random state is equal to 2. So I hope you all know what is the use of this random state. So if you mention this random state is equal to some other number, let's say that you are mentioning this random state as 3, then your data will be split in a different way. So but if you mention the random state is equal to 2, then your data will be split in the same way that my data is getting split. So this is just for the replication of the process, so that there is nothing special about it. Okay, and we are trying to print the number of values for the original data frame, which is my X and my X train and my X test. So you can see here, so totally we had about 195 observations, and the 80% of this observations is 156, which is my X train, my training data, and the 20% which we have mentioned here is my test data, which contains around 40 values. And now we are going to standardize our data, and for this we are going to use the standard scalar function. And if you remember, we have imported this standard scalar function from sklearn.preprocessing. Okay, so I'll go here now and explain you what happens here. So the basic thing here is like we want all the data to be in the same range. So if you look at this, so all the data won't be in the same range. So that is the reason for standardizing it. So you can see here, so we are loading this standard scalar function into a variable called a scalar. So we are loading an instance of this standard scalar function, and we are fitting this to our X train. So the main thing that you need to remember is you should fit your standard scalar function only with your training data. So you shouldn't fit it to your test data. So that is very, very important. Okay, so please remember that. So we are fitting our standard scalar function with this X train, and then we are based on this particular fit, we are going to transform our X train data and my X test data. So the other way of doing this would be, so we would just simply write scalar dot fit transform. So we have another function called scalar dot fit transform, and within this we will mention X train, and what we will do is, so scalar dot transform. So now we won't fit it X test. Okay, so I'll explain you what is happening here. So instead of doing this in two steps, so scalar dot fit X train and then a scalar dot transform X train, so you can just do this in a single step. So the main thing that you need to remember is you have to fit and transform your data using this X train, and you should just transform the data based on this fit. You shouldn't fit your data with your X test. So that is very important. So the reason, so I'll just remove this. So the reason we are doing this is your model shouldn't look at the test data. So that is the idea. So if you just standardize it with the X test data, then it kind of means that the machine learning model has been shown the test data as well, which is something that we don't want. So it should just look at the X train data alone, and that's why we are fitting it with the X train data alone. Okay, so you can just print the X train now, and all the values will be standardized now. And the next part is model training, and this is where the important thing that I have mentioned here. So we are going to use the 4 models in this case. So the logistic regression model, which is very useful for binary classification. So we know that this is also a binary classification problem where we are predicting whether the value is either 1 or 0. And then we are using a support vector machine classifier with linear kernel, and k-nearest neighbor classifier, and finally random forest classifier. And we are going to create a single function that can train the data with all these 4 models, and it can test it with the test data and can print the accuracy score for all the models. So how we are going to do this is, so I'm creating a list, and the name of this particular, so I'll just remove this. Yeah, so I'm creating a list, and I'll just make a text here as list of models. So I'm creating a list which contains all the models that I'm interested in. First is the logistic regression. So we have already imported all the models here. So if you remember, so we have imported logistic regression, support vector machine classifier, k nearest neighbor, and random forest classifier. So we have all the 4 models here, and I'm creating a list which contains all the 4 models: logistic regression, support vector machine classifier, k nearest, and random forest. And I'll explain you why we have the random state is equal to 0 for random forest alone. So let me just complete the explanation for this part. So I'm creating a list, and now I'm going to create a function called as compare models. So the main idea in order to create this function is we are going to compare the accuracy scores. Okay, so instead of training the models separately, I'm going to create a for loop, and when this particular for loop runs for the first time, it will train the logistic regression model. So the first time it runs, this particular for loop will train my logistic regression model with the training data, and it will test it with this test data, and it will give my accuracy score. The second time the for loop runs, it will train my support vector machine classifier with the training data, which is X train and Y train, and it will try to predict the X test data, and finally it will give my accuracy score. So the third time it will train my k nearest neighbor, and the fourth time it will train my random forest neighbor. So this is very simple. So there is nothing complicated in it. I could see some codes. So few people have sent me the codes where this is not like, they have just complicated things. So I just want a very simple code. I don't want a code for several lines that is efficient. So if your code is simple enough, that is completely fine. You don't need to have a large code or something like that. Okay, so we are just creating a simple function in order to do this. So we are creating this function called as compare models, and we are creating a for loop here. So you can see the for loop. So the first step of this for loop is fitting the data to this X train and Y train. Okay, so the basic process that we have to do, the only difference is I'm just putting this in a for loop. And the next step is predicting the test data value. So this is my text data prediction. So I'm training my data with my X train and Y train, and I'm making the predictions with my test data. So this is what I have mentioned here. So you can see here. So like, make sure that you are training your model with the training data, and you are evaluating it with the test data. So evaluating it is nothing but finding the accuracy score. So we are evaluating it with the test data, which is my Y test, and the predictions made by my model is test data prediction, and finally we are printing the accuracy score. So the first time this for loop runs, this model will take the value logistic regression. So the second time this model runs, so the for loop runs, this model will take the value SVC. So this is just like for I in range. So instead of I, we are using model. Okay, so we are printing accuracy score for model. So the first time it runs, this value will be substituted by logistic regression. The second time it runs, the value will be substituted by SVC, and so on. So each time it will take one model, and we will get the accuracy score. So this is my function, and now we need to call this function. So you just need to mention the function, which is compare models, mention parenthesis, and run this. When you run this once, you will get all the 4 accuracies value. So this is what I asked for. So like, I could see few people who have created a function, and in that function they need to give the parameters. Like, they first, when they run the function, they will give the parameters as logistic regression. Okay, so they will do something like this, logistic regression, and the second time they run this, they will give the parameters as support vector machine, and so on. So that is not what I asked for. So what I mentioned is that you need to create a single function, and this function should train all the models separately, and it should give all the 4 accuracy values together. So that's what I asked for. So nothing wrong with that approach as well. So this is like, just a Python exercise for you also, in order to create a specific function for a specific role. So this is how you can create this particular function, where you can train the 4 models, and you can evaluate them. So if you see this, there is a clear accuracy. So like, the accuracy value for this support vector machine classifier is I compared to the other models, and the main reason is that support vector machine classifier works well when we have an I dimensional data. I dimensional in the sense, we have more number of input features. So if you remember, we totally add about 24 input features, right? So in this case, we totally add in 24 input features, and the data set is very small. So this data set contains 195 data points alone. So whenever you have a very small data set, but in that data set, if you contains more number of features, more number of dimensions, then in that case, your support vector machine classifier is the best choice. So I have already explained you this when I made the support vector machine classifier intuition and building it from scratch and so on. So in that, I have mentioned several times that if you have a data set which contains a very small number of data points and more number of features, you have to go with support vector machine, and this is what evident in this case. So as we have more number of features and the data set is smaller, support vector machine is the proper model to use it. So these are all the things that I'm expecting you to do in this particular challenge. So you should be able to convert this data set using some function. So you need to take this text data and convert it to a more sophisticated data frame. So I could see that people have taken a lot of approaches. So I'll go through it and tell you what is the easiest approach and what you can follow and so on. But it is not important. So the main role is you have to get the job done. So no matter what are all the functions that you use, you have to create a data frame like this. So you can see here. So there is an easy way of doing this. So this is somewhat hectic way of doing this. Some people may have figured out an easy way of doing this. They may use a particular function and so on. So I just wanted to show you how you can do all these things step by step. Okay, so that is the reason I've used this kind of approach for transforming the data. And all the other things are simple. So checking the number of missing values, standardizing the data, so we have already learned about all those things. So the only thing is like how you can train all the models using a for loop, and you can print this accuracy scores and so on. And the main thing is that you have to have this inference here. So why support dictated machine classifier works well on this particular data set. So this is all I am expecting. So I will go through all the codes that you are submitting. So by this time I received about 10 codes. So 10 people have completed this challenge by the time I'm making this particular video. So I'll go through all of those codes, and I will mail you regarding your code. So what are all the errors there, or what are all the things that you have done better, and all those things. Okay, so that's it from my side, and I hope you have understood how you can solve this particular challenge. And again I'm telling you, like, I wouldn't say that this is the only way of solving this. So that is not what I'm saying. There are a lot of ways that you can solve this. That, like, this is just my approach. Okay. So there is nothing wrong in your approach. So just that you have certain limitations in your challenge, and I will evaluate it based on this limitation. So that is one thing that you need to remember. So this will definitely help you on your learning journey. So this will be a more hands-on session where you can figure things out on yourselves, rather than I'm explaining you all the things. So that is the idea of creating this challenge. So I'll try to do this challenge once in a while so that we can have a better learning process. Okay, so that's it from my side, and I'll see you in the next upload. Thanks for watching.